So let us start KDM lab. Let us start KDM lab. So we already discussed about your syllabus and everything. Here let me discuss the compound pendulum. And this may be the tabular column. We are going to insert compound pendulum on knife edge. So there are two positions. So you need to measure the positions with respect to the center of the pendulum. Okay, that you are going to note here. It's noted here, and you are going to take time taken for 10 oscillations. The remaining part are calculations. Okay, so this is what the required tabular column, and these are the formulas to calculate. Okay, so you'll get the readings like this. I'll show how to take the readings. Okay, so please go through this video.
Sir, audio varla sir.
Are you able to understand? Puridapa experiment.
Sir, audio கேக்கல sir.
Oh shit. Okay, again I'll share. Distance. There are 5 zones. Distance. First we are going to insert the first pole to the knife edge. The distance between knife edge and the center is measured. Then we are going to take time taken for the oscillation. In oscillation, now we are going to take time taken. But don't follow like this. Okay, we are going to take time taken for oscillation. Now first one. So if it starts from here, you come back to this position. Then we have to take this first one. The aim of this experiment is you need to calculate mass moment of inertia. Okay. Puridapa.
Okay sir.
Okay. Next let's start to discuss suspensions. Bifilar suspension or trifilar suspension. Wait, I'll show. Students, this is trifilar, bifilar. Okay, before start, let's discuss the tabulation. Okay, here I'll show the tabulation for bipolar suspension, very similar to compound pendulum, but here you are going to take circular oscillation. So I'll explain in experimentation. These are the readings you are going to take, and I'll change the readings accordingly. Okay. So this is what your calculation procedure. It is very similar. So the observation of this experiment is you need to measure string length, cord length, string length L, cord length 2A, and length of the plate. Okay. So now let's start. Students, this is bifilar suspension. So there are two suspension points. The observation of this experiment is you need to measure the length of the bar, distance between the string, length of the string. Okay. Next, you are going to add the weight to the load band. Then you are going to make the oscillation. Listen. So one count. So like that, you are going to take time taken for 10 oscillation. Once I will show. So it starts from here. So count 1. So like that you are going to take 10 oscillation time. Okay. That's it. Next, let me start to explain trifilar suspension. Both bifilar and trifilar is very similar. Here the difference is there you are taking length of the plate. Instead of that you are going to take diameter of the plate. That is what the similar difference. Instead of 2 suspension, here you have used 3 suspension. So let me explain. Next, trifilar suspension. There are 3 suspension points. Observation of this experiment is you need to measure the length of the string, distance between the string 2A. Next, trifilar suspension. There are 3 suspension points. Observation of this experiment is you need to measure the length of the string, distance between the string 2A, cord distance, diameter of the disc. Then you are going to load add the load pen. We are going to take oscillation. So note down. So like that, keep and leave. So you need to wait for 10 oscillation. You need to take the time taken with the help of stopwatch. This is what the experimental procedure for trifilar suspension. Okay, sir. Next, let me start to explain spring mass system. Longitudinal vibration. Okay. So please go through this. This is what the required tabular column for spring mass system. So you need to measure length of the spring, deflection. You are going to add the load incrementally 100 grams. You need to measure length of the spring before loading, after loading. You need to measure deflections. You need to take number of 10 oscillations, the time taken for 10 oscillations for 3 trials. Here I will show 5 trials. It's up to you. Then remaining parts are calculation. This is what the calculation procedure. You need to find ultimately frequencies. Okay. Let me explain. Please go. I am going to perform longitudinal vibration. So this is the spring we are going to perform longitudinal vibration. So this is the spring we are going to use. First, the observation of this experiment is you need to measure the length of the spring, mean coil diameter and diameter of the spring. Okay. First, we need to measure the length. Then you are going to add the weight. So here I am going to apply the weight 200 grams. While applying, you are able to notice that there is change in length. First you need to measure initial length, then you are going to measure this change in length, you are able to calculate deflection. The experiment is once you are load, then you are going to oscillate. So like that it is going to oscillate. So you are going to take time taken for 10 oscillation. That's it. Puridapa, able to understand now what I said?
Yes, sir.
Purida. Next, let me discuss motorized gyroscope.
வேற ஒருத்தரும் மாத்தி சொல்லுங்கப்பா, ஒரே ஆளே பேசுற மாதிரி இருக்கு. இட்ஸ் நாட் ஃபேர். This is what the tabular column for motorized gyroscope. I'll tell the experimental procedure. Here you are going to measure speed, load, precision angle, time taken for required precision angle. Remaining things are calculation. So let me explain the calculation. It's very simple. You calculate So first you need to calculate omega p, omega, if n is known, omega able to calculate omega p, precision angular velocity. If time taken of our angle and precision angle time taken is known, you able to calculate omega p. Then the applied load, you able to calculate active gyroscopic active couple. If you know omega p, mass moment of inertia, you able to calculate reactive gyroscopic coupled. Let me explain the experimental procedure.
Guys, this is motorized. Guys, this is motorized. So guys, this is motorized gyroscope. The observation of this experiment is you need to measure the center distance of the disc to center distance of the load pan. Next, the diameter of the disc you need to note down. Typically, let me split around 700 rpm. So rotor is going to rotate. So let me wait.
பா கேக்குதாப்பா? நெட் டிஸ்கனெக்ட் ஆயிருச்சு. ஹலோ 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 கேக்குதாப்பா? ஹலோ ஹலோ கேக்குதா?
எஸ் சார்.
கேக்குது சார், கேக்குது சார்.
ஹெச்ஓடி கால் பண்ணி நெட் டிஸ்கனெக்ட் ஆயிருச்சு. உங்களுக்கு மோட்டரைஸ்
கேக்குது
கைரோஸ்கோப்
சார்.
போனது தெரிஞ்சுதா? எங்க கட் ஆச்சு? ஹலோ எந்த இடத்துல கட் ஆச்சு? எப்ப நான் டிஸ்கனெக்ட் ஆனேன்? ஹலோ
சார் அந்த
ஹலோ
மோட்டரைஸ்ட் கைரோஸ்கோப் வீடியோ ஸ்டார்ட் பண்ணும்போது
சரி நான் ஒன் செகண்ட் go through. புரிஞ்சுதாப்பா? புரிஞ்சுதா? Are you able to understand? புரிஞ்சுதா? Are you able to understand? Hello? Are you able to understand?
புரிஞ்சுது சார்.
Okay, next experiment. Let me discuss. Transverse vibration of cantilever beam. Transverse vibration of cantilever beam. And this is what the calculation procedure. Here you measure
Sir,
time taken for
screen
10
share
oscillation.
screen
Hello?
share ஆகல சார். screen share ஆகல சார்.
Screen share ஆகலையா? அப்ப அந்த வீடியோ மட்டும் தெரிஞ்சுதா?
எந்த வீடியோ சார்?
ஆ?
கொஞ்ச நேரமாவே ஸ்கிரீன் ஷேர் ஆகல சார்.
அப்போ நீ அப்பயே சொல்லிருக்கலாம்ல, அந்த வீடியோ தெரிஞ்சுதா? கைரோஸ்கோப் வீடியோ. இப்போ தெரியுதாப்பா?
இப்போ தெரியுது சார்.
ஓகே ஓகே ஓகேப்பா. Cantilever, transverse vibration of cantilever beam. So we have two, transverse vibration of cantilever beam and simply supported beam. Very similar procedure. You need to change the formulas. Ultimate aim is you need to measure transverse vibration. So you need to compare experimental and theoretical frequency. Okay. Aim of this experiment is you need to calculate frequency. Next observation is you need to measure time taken for 10 oscillation. You need to measure length of the beam. Next, let me explain the experimental procedure. Please note it down. Cantilever beam.
Okay, sir.
Guys, this next experiment is transverse vibration on cantilever beam. Guys, this next experiment is transverse vibration on cantilever beam.
தெரியுது சார்.
Okay.
Guys, this next experiment is transverse vibration on cantilever beam. This is what your experiment. Okay, we are going to take this two types of reading. One is loaded at the end. So you are going to load it at the end. You are going to add the incremental load. You are finding out the vibration frequency of the system. Okay, observation of this experiment is you need to measure the length, breadth, thickness. These things you need to measure. Okay, first here I am adding 100 grams weight oscillates. So I am going to take time taken for 10 oscillates. Next, incrementally I am going to add the weight. Again I am going to perform the experiment. Next, incrementally I am added the weight and again perform the experiment. So, with the help of stopwatch, I am going to take time taken for 10 oscillations. This is what the experiment. Next, this is loading at the end. Next, we are going to take the same set of readings. So we are going to take 3 trials, same set of readings for concentrated load. So this is what the procedure for concentrated load. So here I am, guys listen, here I am adding 100 grams each at 5 different positions. Okay, so you able to notice now. So in this case, you need to measure each loading distance. This one and this one, this one, this one, this one. With respect to one end, you are going to measure all the distance. Else, you are going to measure each equidistant. Now, the experimental procedure is you are going to oscillate and you are going to take time taken for 10 oscillation. You are going to do this for 3 trials. This is what the experiment of cantilever beam of transverse vibration. Here.
Next, let me explain simply supported beam. Transverse vibration for simply supported or fixed beam.
They are going to keep a load at the center. They are going to keep a load at the center. So first initially you keep 100 grams. 100 grams are going to take the reading for oscillation, 10 oscillation. Then you are going to increase the load. So this is the first step, load at the center. Then you are going to increase and you are going to take time taken for 10 oscillation. This is load at the center. And next, the concentrated position. And let me keep it. Position. Keep the load in this station and we are going to take the reading. Okay, this is concentrated position like previous experiment. So like this also we are going to take 3 times. So keeping the load at 1 to 5 different positions. We are going to measure this distance. Here also the observation is you need to measure the length and length between the loading positions, depth, thickness. That's it. Next, single rotor system. Sir.
Okay, next let me explain motorized universal governor.
Governor, here we are going to perform 4 different experiments. Watt governor, Porter governor, Royal governor, Hartnell governor. So already we discussed about the configuration. Let me consider this is what the initial position of Watt governor. And if you want to do Porter governor, you need to add this sleeve weight at the center, losing the nut, and you are going to insert this weight. Then the configuration becomes Porter governor. Next, you want to perform remove these 2 arms and you are going to insert this. So it will be like this. I'll show you how it becomes. Okay, so it will be like this. We are going to insert. Okay, in this manner. Next configuration. Remove these 2 upper link and they are going to insert this. Then the governor becomes Royal governor. If you want to perform Hartnell governor, insert the spring. Other 3 configuration dead weight will be at the center. So that you need to remember. Okay. For Hartnell governor, you need to keep this arms and you are going to insert the string. That is what the position for Hartnell governor. Okay. So let us start the experiment.
அப்படியே அப்படியே ஆன் பண்ணுங்க.
Before start the experiment, you people must ensure the initial distance of the sleeve. Okay, so you have to notice down now. So it rotates around 11 centimeters. So you able to see now. So this you need to take care. Okay, I need to ensure every nut and bolts are tightly connected. Okay, then it is ensure the safety of the student. Okay. Okay, let me start the experiment. So we are going to take 3 sets of readings for 3 different speed: low speed, medium speed, high speed. So let us consider for 2 centimeter incremental value. If it is 11 to 13 moves, let us consider low speed. So 13 to 11 to 13, 13 to 15, let us consider it is medium speed. So 15 to 17, let us consider it is high speed. So we are going to take the speed with the help of digital tachometer. If you are striking the digital tachometer here, you are able to get the speed. This is not the procedure. So let me start. With the help of your start, I am going to feed the current. So you are able to notice. See, while the speed increases, sleevelets to move. For particular sleeve distance, we are going to note down the speed. This is what the experiment of governor. Once you finish the experiment, zero down the experiment. That's it.
Let me discuss Hartnell governor. It will give the clear idea.
So guys, this is Hartnell governor position. So we are going to do Hartnell governor experiment. Already I explained the governor experiment. This is what the position of Hartnell governor. If this spring is taken out, then it becomes Royal governor. Okay. Other 2, Porter and water governor configuration, you already known very well. Okay, let me start. Before start the experiment, you need to note down this initial distance. So here we are going to take 3 different speeds: low speed, high speed, medium speed, high speed. Okay. First, let me feed the speed with the help of your start. See, now it deflects. So you need to note down the speed with the help of tachometer and note down the deflection. This is what the experiment of Hartnell governor.
Next, let me explain whirling of shaft.
நீங்கள் கவரமோ நீங்கள் கவரமோ
Guys, our next experiment is whirling of shaft apparatus. So this is what the whirling of shaft apparatus. Here are Aim is we are going to take the critical speed. We are going to measure the critical speed experimentally with the help of tachometer while striking the light here. Able to get the required critical speed. Now, this end you are going to connect with the help of chuck, and this end you are going to connect with the help of this collet, this type of collet. So here we have this end. Next, observation is you need to measure center to center distance of this length, diameter of the shaft, weight of the shaft. Okay, here let me fix aluminum shaft having diameter 6 mm. Okay, so let's start the experiment. Yes, start it. With the help of Rio starter, here the feed. Initially it rotates circular orbit, but it keeps increases.
Next, let me explain vibrating table.
Students, the next experiment is vibrating table. This is what the vibrating table experiment. Okay, here the experimental procedure is this rotor produces a deflection, and that means this rotor produces an unbalance to the system, and this spring provides a deflection. So like this. So here you have a graph plotter. So with this plotter, be able to get the reading. This is what the experimental procedure. So let me show. While this runs, it will oscillate like this. If you are inserting a pencil here, you are able to get it. So like this. It shows like this. The paper feeder, it will show the reading. If you are inserting the pencil, it will move like this. So let me show the. This is what the working of magnetic table.
புரியுதாப்பா experiments?
புரியுது சார்.
Okay, I'll give the readings. You need to write. I'll give the records, tabulations, everything. I'll give the readings. Let us conclude the lab session. You need to submit accordingly. Okay, va? So next 15 days you need to submit. Okay, you able to understand now what is it? So submit as soon as possible.
Okay, sir.
Okay, let us start to conclude.
Okay.